Hello, let's start off section 2.3, where we're going to start answering a question of how to evaluate limits. So in the previous section, we did it kind of informally with pictures and with data, but we couldn't, say for certain exactly what the answer is. And so in this section, 2.3, basic limit laws, we're going to start answering the question of how to really evaluate limits. And so, for example, we'll start, one of the problems that we'll look at later on is going to be something that looks like limit as t goes to 3 of t to the minus 1/4 times t plus 5 to the 1/3 power. So this is something that if you had a computer, you could plot it to try to figure out what the limit is. If you had a calculator, you could calculate out lots of terms, lots of points of this function for values of t close to 3 to try to figure out what's going on. But we'll see how to do it just by hand. And so in order to do that, there are going to be 5 basic limit laws for us to look at here. And so let me I have written them out. They're kind of long statements. I didn't want to copy out for you on the video, so you can just copy this down at your leisure. You might want to pause the video at some point. But let's talk about this moving through it. So we're assuming that we know some limits exist. So we know that the limit, so let's say that I tell you that the limit as x to the c of fx is some number. I tell you the limit as x to the c of g of x is some number. There's lots of things that we can find from this. So the first thing is we have a sum law, which just says that the limit of the sum of f of x and g of x exists, and it's equal to the sum of the limits. So there's actually 2 statements in here. If you look at the textbook, it will write out to a little bit more detail than I'm doing. I'm writing a little bit more succinctly, but I do want to emphasize the fact there's 2 statements here. The first statement is that the limit of the sum exists. We saw in section 2.2 that some limits might not exist. So merely being able to say that some limit exists is a significant thing in and of itself. But not only can we say the limit of the sum exists, but we can also say it's the sum of the limits. So that is the first thing that we know. The second basic limit law that we have is a constant multiple law, which says take a constant k, like 7, the limit of k times your function, it exists, and moreover it's equal to k times the limit of your function. So the limit of 7 times f of x is equal to 7 times the limit as x goes to c of f of x. Again, this should be unsurprising. This should be expected here, but it's worth noting these things down. So we can multiply by constant, we can add things together. You might start thinking about what else can we do. So another thing is that we can multiply our functions together. If we want to take the limit of f of x times g of x, well, as x goes to c, well, that assuming that our original 2 limits exist, well, this exists, and is exactly what we would expect it to be, that we merely multiply together the corresponding limits. So we have a sum law, constant multiple law, a product law multiplying the 2 functions together. Start thinking to yourself what's coming up next. And unsurprisingly, the next one is going to be a quotient law. So this one we can summarize as the limit of a product is the product of the limits. And so the quotient law says that the limit of a quotient is the quotient of the limits, but realize there's one special thing we have to throw in here, which is that we don't want our denominator to be 0. So limit as x goes to c of g of x is not equal to 0, then we have this quotient law. And it's worth really emphasizing this, that we don't want limits x goes to c of g of x to be equal to 0, because many of the really important cases that we'll deal with throughout the rest of this chapter, throughout the next chapter, is going to involve cases where the limit of the denominator is 0. And so then we can't apply this quotient rule. We have to do different manipulations in order to make it work. And then our fifth law is going to be the power law / the root law, which says that the limit as x to the c of some function raised to the n power, like we could be cubing this here, the limit as x to the c of f of x cubed is take the limit and then cube the limit. So we can interchange the order of the limit and this exponent here. We can also do this for roots as well. The limit as of the nth root of f of x is the nth root of the limit. In case n is even, we have to have this non-negative assumption. And we can do this even for fractional powers, that the limit as x to the c of f of x raised to some fractional power, assuming we might have to assume some kind of parity here of the of q here, but again, the limit of some function raised to some rational power is going to be that limit raised to that rational power. So we now have 5 limit laws, sum, constant multiple, product, quotient law, and a power law in our pocket. And we also have 2 more rules that we talked about in section 2.2, which is the fact that the limit as x goes to c of some constant k is k. So this is a constant here. And then the limit as x goes to c just of x is equal to c, whatever is the point that we are doing a limit around. And so these 5 laws and these 2 facts, in the next video, we'll see a lot of ways to apply these to answer lots of questions very quickly.